Hello guys, today we're doing LeetCode question 231, power of 2. Question is, given an integer n, return true if it is a power of 2, otherwise return false. An integer n is a power of 2 if there exists an integer x such that n is equal to 2 to the power of x. So example 1, n is equal to 1, the output is true because 2 to the power of 0 is equal to 1. Example 2, n is 16, the output is true because 2 to the power of 4 is equal to 16. Example 3, n is 3 is false, because no 2 to the power of nothing can become 3. And the way we'll do this is pretty much by getting the value and looping through it as long as it's a whole number. And then each time we set n to its n divided by 2. Because as a 2 to the power of 2, every time the value is multiplied by 2. So we just have to divide it by 2 to get the reverse. So I'll show you here, for example. Let's say we have 16, right? That is n. Now, we know that 2 to the power of 4 is 16. Reason being is 2 times 2 is 4, times 2 is 6, sorry, not 6, 8, and times 2 is 16. So the way we'd reverse it, just pretty much do the reverse. Let me keep that there. We do 16, instead of times 2 divided by 2, which is 8. Now 8 divided by 2, instead of times 2, is equal to 4, and 4 divided by 2 is equal to 2. So this is pretty simple. We'll just loop through it. So as long as the value modulo 1, so as long as it's divisible by 1, then we know it's a whole number, and we continue halving it. Now, if we come across n being 1, that means that the value is divisible by 2, and so it is a power of 2. Otherwise, if we don't, we return false. So the reason being that we check if it's divisible by 1, let's say the value was 3, for example. We try to see, is 3 divided by 2 a whole number? It won't be a whole number because half of it is 1.5. So we know it's not divisible by 2 and so it's not modulo of 2. So let me show you how we do this in code. So the first thing we do is we create a base case. If n is equal, well, let's do smaller than or equal to 0. Because if it's a negative number, then we know it can't be divisible by 2, and if it's 0, it can't be divisible by 2, so we return false. Then we loop through n as long as, so while n modulo 1 is equal to 0. So as long as it's divisible by 1, and it's a whole, it will pretty much check if it's a whole number. The modulo is a remainder, so if n divided by 1 is a remainder of 0, then we know it's a whole number. Now we check if n is equal to 1, then we return true, because we know we got to the bottom of it, and all of the numbers are pretty much a power of 2, or result is a power of 2, because we can divide it by 2 up until 1. As you can see, 1 is 2 to the power of 0. And then we check, then we every time we half it, so n is equal to n divided by 2. Now, if this while loop finishes and we haven't returned true, that means we have to return false, as it's not a multiple of 2. Now let's see if that passes. It does. Let's submit. As you can see, this is one of the fastest methods. This is a time complexity of O log n, because we're halving the value each time. So it's not O of n, because we're not looping for each value n, but halving the value of n each time. So that's time complexity of O log n. And this is a space complexity of O1, as we're not storing any extra variables. Thanks for watching.